Welcome back to FaceItNet. Today, I'm going to teach you, or I'm going to talk to you guys about IPv4 addressing system. So far in all our practicals, all the machines had an identification number. We talk about 192.168.10.20, we talk about 172 some numbers, and then we talk about 10 range of numbers. So we talk about a lot of numbering systems when we come to a networking part. But what's behind this numbering system? What is this number, right? How these numbers are structured. So let's go have a look at IPv4, which is the numbering system that we discussed before and we have been using forever in the systems. If two devices need to communicate on a network, they should be identified uniquely about their identity. So the unique identification system here is called IP addressing. It could be within the local area network or it could be outside the local area network, but still we need to identify the devices. Of course, I know in local area network we can identify them using MAC addresses, but still you have another unique identification system which is called IP addressing. So without further ado, let's go have a look at IPv4, right? So IPv4 is a 32-bit logical addressing system. So keep in mind it's 32-bit and it's a logical numbering system. So any IPv4 address has 32 bits. Bits means it's in binary. But remember, you cannot remember 32-bit binary numbers every time. If someone come and ask you what's the computer identification number or what's the IP address of the computer, if you have to say that in binary, then you're going to say 0.0.1.1.000111011200000, so something you have to say a 32-bit number. This is practically not possible. So we humans are used to follow the numbering system called decimal numbering system. So if I been given a number in decimal which I can remember easily. So what then we have done, instead of using this 32-bit binary numbering system, we convert that into a decimal numbering system, right? So the 32-bit binary has been changed into a decimal numbering system. But then I said logical address. What is logical address? Logical address means the numbers can be changed, right? There is no a permanent number that you can change this number. We have a physical addressing system that's called MAC address. MAC addresses are burnt into that network interface cards, so you cannot change those numbers, right? But physical addresses are something that we assign, so we can keep on changing these numbers based on our network addresses. So in terms of IPv4, it is a 32-bit numbering system and it is a logical addressing system assigned to every single network devices. If a device needs to communicate over a network, then it must have an IP address. So as I said, 32-bit numbers, it's really tough to maintain and really tough to manage and remember. So we have converted into a decimal format. So how do I convert that 32 into decimal? So the easiest way what the IP addressing system is using, they divide this 32-bit into 4 groups of 8 binary numbers. So the 32-bit is divided into 4 8 binary numbers. So here we got 8 binary numbers, and the second set we got an 8 binary, another 8 binary, and another 8 binary. So total of 32 binary numbers. To separate them, between every 8 bits we put a dot. So we have a dot between every bit. So it's become 8 bits format, right? So we call it as a 4 octet separated by a dot. So you got 8 bits, then a dot, then a 8 bit, then a dot, then another 8 bits, and then a dot, and then another 8 bits. So when I say 8 binary numbers, a binary number can have the lowest value of a binary number is 0. The highest number is 1. So this is for one binary bit. So if you see 8 binary numbers, they can have the lowest of 8 zeros, right? So you can have 80 as the lowest number, and you can have 81 as the highest number. If you see 80, and if you convert that 80 into decimal, that's 0 in decimal. If you convert 8 ones into decimal, that's called 255, right? If you convert 8 binary number to decimal, it becomes 255. So an IP address is going to start from 0 for the first octal. For the second octal, the lowest one is 0. The third octal, the lowest one is 0. For the fourth one, lowest one is 0. The highest one is going to be 255, right? The first octal, the highest is 255. Second, the highest is again 255. And for the third one, again 255. For the fourth one, it's going to be 255 too. So an IP address is going to be from the range 0.0.0.0 to 255.255.255.255. That's a huge range. If you look at it, how many numbers are there? That's almost around 4.3 billion numbers, right? It's not million, it's in billion numbers. So you cannot remember and manage this many numbers. So what they have done is then they divided this into smaller groups. So we will go and talk about the groups after this, but just keep in mind, it's a huge range of IP and you can't manage it. But we have got 4.3 billion numbers. That's what it says, 2 to the power of 32 numbers. Why that we have 2 to the power of 32 numbers? If you see one binary number, the possibilities of the values are 0 and 1, so 2. If you got two binary numbers, you can have 0, 0 and you can have 1, 1, right? Or you can have 0, 1 and you can have 1, 0. So you can have 4 different numbers. So if you have 3 binary numbers, you can have 8 different bits, which means 2 to the power 3, that is equals to 8. So here in IP version, we have got 32 bits. That means 2 to the power 32, which is about 4.3 billion numbers. Even though we have got 4.3 billion numbers, we cannot use entire range of IPs here. Some of the IPs can be used, some of the IP addresses cannot be used. In every IP class, as I said earlier, to manage these IP addresses, we have divided into number of classes. There's about 5 classes: class A, class B, class C, and class D, class E. So every class has a range. To cover the whole range of this IP, we divided into 5 different ranges. Within every range, we can use some of the IP addresses, and some of the IP addresses cannot be used to go to internet. If an IP address can be used to go to internet, then we call it as a public IP address. If the IP address cannot be used to go to internet, then it's called private IP address. So the whole IPv4 address is divided into 2 components or 2 groups, major groups. One is called private IP, the other one is called public IP. So the whole range of IP is from 0.0.0.0 to 255.255.255.255. To manage this easily, we divide it into multiple groups. So let's see what are those groups. So we have class A, class B, class C, class D, and finally we have class E. I didn't really write class E because it's for the testing purpose, so I don't really bother to write it. So class A, as I said, the smallest range starts from 0.0.0, and the last number here in class E, if you look at it, that will finish in 255, 255, 255, that range. So the entire range is being used, see, 0 to 255, the whole range is used. But then we divide this range into a multiple range. That's it. So for example, it's all start here 0, 0, and it goes up to 255.255, 255. But then we break them into multiple ranges like this, right? So this becomes a class A and class B, class C, class D, and then class E, right? We divide them into multiple classes. So the class A range is from 0.0.0.0 to 127.255.255.255. If you add 1 to this, class B starts. It starts from 1 to 8 and goes up to 191. 255, 255, 255. Add 1 to this, that starts from 192. It goes up to 223. Add 1 to this, starts to 24. So here again, add 1 to this, the next group start from 240, right? So class E start from 240.0.0.0 and goes up to 255.255.255.255. So the entire IP is divided into 5 classes. Class D IP address are used for multicast purposes. Remember, a network communication can be a unicast, multicast, or a broadcast. So A, B, and C are used for unicast communication. Class D is used for multicast communication. Class E is reserved for testing purposes, right? See, experimental purposes. So in a network, I can only use class A, class B, and class C IP. You are not going to see class D or class E IP addresses assigned to any devices in a network, right? So keep in mind, class A, class B, and class C are the IP addresses that we are going to use it. Even though we have range starting from 0.0.0, we are not using anything with starting 0. So technically, the practical IP address, first practical IP address starts from 1.0.0.0, and it will go up to, we don't even use 127, we use only up to 126. This is only in class A, right? Not in the other classes, but in class A, we are not going to use up to 127. We are going to use only up to 126. The reason 127 IP address is a special IP address. We use it for a special purpose called loopback. I have a slide later on this one, and I'll explain to you that later. So this is the first and this is the last IP in the class A. In every range, right, every IP, there are multiple components within the IP address. If you see an IP address, it's a combination of two portions. One is called host portion and the other one is called network portion. We will talk to that information later on, but keep in mind, within every IP address, we have a host portion plus we have a network portion, right? So in general, class A, B, and C are used for unicast, class D is for multicast, class E is for experimental purposes. So that gives you a total understanding of table. So you can see class A we use from 1 to 126, 127 is not there, 128 to 191, then 192 to 223. And here it gives you the valid range. Here it gives you the valid range of classes and how many possible IP addresses are in this network. Sorry, how many possible networks, because see, this component, the first digit of this class A is called network, right? This last three components is called host portion in class A. Class B, first two digit is considered as network, last two digits considered as host. Class C, first three digit considered as network, last one is considered as host. So if you keep on changing the network bit, you will get new different networks. So here the possibilities is you can only change this bit. So you can change from 1 to 126. So there's only possible of 126 different networks we can have in class A. Each network is going to have this many host bits. So how many bits are there? 3 octal numbers or 3 decimal numbers. Each decimal has 8 bits inside. So that's mean 2 to the power of 24 host bits is possible in class A, right? It's a massive, see here, 2 to the power of 24 is possible in class A. If you see class B, we can change this bit from 128 to 191. Second bit can be changed from 0 to 255 times. So this from 128 to 191 times, and here we change this one again. So pretty much we are going to have, this is around 63 and this is 255. So 255 times 63, this is going to be around 16,000 different networks. How many host bits are there? As I said, these two are the host bits. I can change this one from 0 to 255, and this bit also can be changed from 0 to 255. So it's going to be 255 times 255, which is 2 to the power 8 times 2 to the power 8, so 2 to the power 16. And then there's a minus 2. I'll explain why these minus 2s are there. I'll explain that later on. But we can have 2 to the power of 16 different hosts, which means we can have that many devices in that network. this many devices, 16,384 networks, and inside each networks we can have around 65,534 IP addresses. In class C, the first 3 bits is for your network, right? First 3 bit is your network bits. So class C, I can have around 255 times here 255, here another 255, so this is 255 times 255 times from 192 to 223 is 32. So that's what this number. You can see when we come from class A to class C, number of network is increasing. See, here it's only 126 networks. This is 16,000 network. Here you have got around 2 million networks. Whereas the host per network is changing. See here, host per network is millions. It has come down to 65,000. Now that has come down to 2 to the power 8, which is 256 minus 2. So 254. So we can have only 254 IP addresses per network. But how many networks? 2 million networks. Here, millions of IP addresses, but only 126 networks. So few number of networks and massive number of IP addresses per network. Here, lot of networks, but fewer IP addresses. That's why we can see in most of the network, people are using 192 IP addresses because it's a smaller network. All our LANs are smaller networks, so we use this network. Right, so the rest of the information is like basic information, how many host bits and how many network bits. As I said, this is your network part. So 1 bit, 1 octal, 1 decimal or 1 octal, so that's mean 8 binary, and 3 decimals or 3 octals, so that's mean 24 decimal numbers. So this is the information about IP addresses per classes. Here we have something here, it's called subnet mask. Subnet mask is used to identify the network. To divide the host and network portions, we use subnet mask. I'll come back and explain that later on in the new slides. So don't worry about that now. We will focus only about IP addresses. So class A, class B, and class C. It gives you a complete idea. See, class A, you have 126 networks. Each network can have 16 million IP addresses. Class B, 16,000 networks. Each network can have 65,000 devices. Class C, you got 2 million network, but the number of devices per network is reducing. So that's how the networks are designed. If your network has got more than 254 devices, you are forced to go to class B IP addresses. If you want to maintain every device under one network, so you need to go to a class B IP. If your network is bigger than 65,000, then you need to go to class A network. You can have multiple class networks. So you can have 192 network and 193 networks. Or you can have 192.168.1 dot network, 192.168.2 dot network. So you can have 2 separate networks, but then your devices are not in the same network. They are in 2 separate networks, and there should be a routing to communicate between the devices. So the easiest is to go to the class B, so you can assign it. Right. We're talking about class full IP addresses. We'll come back to a concept called classless later on. So this is numbers. It gives you the numbers. How come we got these numbers, right? This table gives you, say, class A network. It's only 8 host bits and 8 network and 24 host. Class B, 16 host, 16 network. Class C, 24 network and 8 host. That's mean 254 IP addresses and 2 million networks. 65,000 IP addresses, 16,000 networks. 8 millions or some millions of 126 networks and millions of IP addresses possible in that network. So we talk about these numbers. We talk about the IP address. We talk about the classes and then the range. But keep in mind, when I go into this slide, I explained to you there is something called a private IP and public IP address. So what is private IP, right? So keep in mind, private IPs are referred as RFC, reference 1918. So this reference means it talks about the private IP addresses. So there is a reason why we are using private IP address, because the demand for the IP address and the number of devices connected to internet is increasing in an exponential way. So the IP address we have is only 4.3. That is not really enough for us to use it. So what happens is, to save the number of IP addresses to connect to internet, they introduce a concept called private IP addresses, where you can put multiple devices and you can connect them internally, but they cannot go to internet, right? So that way I can avoid all the devices connecting to internet. But keep in mind, when they introduce the IP address, the whole concept is for every end devices must have a unique IP address that can be traceable and easily reachable over the internet, which means there should be a end-to-end connectivity. But after the introduction of RFC 1918, the end-to-end connectivity is being disabled. The reason, there is a concept called NAT introduced. So the devices with private IP addresses cannot go to internet, and they have to use a concept called NAT to go to internet. So without further we go into NAT, let's come back to the private concept. So when we say class A, class B, and class C IP addresses, the ranges are starting from 1 to 126, and then the next one start from 191, 128 to 191, then 192 to 223, right? In this range, these are all IP address, but in this range, every class has a private IP address. In class A, anything starts from 10 dot range is considered as a private IP. In class B, anything start from 172.16.0.0/16. 16 means it's a subnet mask. From there to 172.31.255, or let's say 0.0, is considered as private IP. Similarly, in class C, anything start from 192.168.0.0/24 to 192.168.255 is considered as a private IP address. So these three IP addresses you can use into any devices in your local area network, and you don't need to purchase it. Anything apart from these numbers, if you are going to use on your devices, you must purchase it. If you're in Australia and if you purchase an IP address, a public IP address, you need to pay $10 per month to keep that IP addresses, right? So these addresses are not routable IP addresses. You cannot use these IP addresses to routing purposes. Nobody owns these IP addresses. That means anyone can use these IP addresses. That's why it's called free IP addresses, right? So RFC 1918 means it's about a private IP address concept. So every class A, class B, class C, has a private IP address. Class A range is from 1.0.0.0 to 127.255.255.255. In that, we are not going to use 10 IP addresses for anything to connect to internet, right? But keep in mind, every device has this IP address today. If you look at your local area network, every computer has this IP address today. As I said, if I use this IP, you can't go to internet. But then you might have a question, how come then I'm going to internet? The answer is NAT. Your private IP address goes to your gateway, and in your gateway, they will convert this into a public IP address and go to internet. So on the other side of your network, whatever the destination can see you as your gateway's public IP address. They're not going to see your private IP address. When they reply the packets, it comes to your gateway. In your gateway, they maintain a netting table. The netting table will maintain the conversion of private to public, and then they will forward back into your local area network to reach it out. So that's how the internet works. So don't worry about it, but just keep in mind, private IP address cannot be used to go to internet. Here we go. In this table, I have given that clearly. So anything start from 10.0.0.0 to 10.255.255.25, because it's a class A. That means first digit is your network. The last three is your host portion. So you can change your host portions to get a new IP address, but your network bit will not change. In class B, anything start from 172.16 up to 172.31. So you have pretty much 15 networks with 2 host bits. Class C, anything start from 192.168.0 to 192.168.255. So that means you can change this bit from 0 to 255. So you can have 255 networks, private networks, and each will have 255 IP addresses. So that's considered as the private IP address range. And then keep in mind, I didn't talk about the IP 127. See here, 1 to 126, and we missed out the 127 IP address. The reason 127 IP address is called loopback. This is for piggybacking, pigback IP address. So what we do is with this loopback IP, we can ping back to your device, which means this is for mostly testing for your TCP/IP interfaces or TCP/IP protocol suite to make sure your TCP/IP protocol suite is working. So entire 127 range of IP addresses is block is reserved as a loopback range. The commonly used IP address people used to say ping to your local area network, local IP address and see, or ping to your loopback to confirm whether everything is working, the protocol set. This is called localhost. If you have a destination 127, that means you are not sending the packet outside your device. You are sending the packet to your network interface card and receiving from your network interface card. That's why it's called loopback. You send it and receive it back within the same device. It's considered as loopback. So that's pretty much about IP addressing. So that's all about IP addressing. So quickly go back here. For IP address, it's a 32-bit, it's in decimal format, and you have 2 to the power 32 binary numbers, right, which is 4.3 billion. It's divided into private and public. Entire IP range divided into 5 smaller classes, class A, B, C, and D, E. Class A, B, C is for unicast, D is for multicast, E is for reserved for experimental purpose. And then each class has got different range of IPs and hosts and networks. Then how many networks and how many hosts are available in each networks. Out of that 32-bit, how they are divided into network and host, and then private IP address, the range of the private IP addresses. Then finally we talk about loopback. So that's the simple introduction of IP addresses. We will go into further IP addressing concepts later on in another lecture slide. So keep watching this space and I'll upload another video with more IP addressing topics. So we will go into classless routing, classless IP addressing, subnet masking, VLSM, variable length subnet masking, and many more in IP addressing. Then we will have to move on to IPv6. Right, stay tuned and make sure you subscribe to FaceItNet channel. So I'll post you more and more videos. Thanks for watching.